Welcome back to Think Design Works Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios, and what I have for you today is a continuation of our series on architectural styles. We today discuss about hexagonal architecture, or its better name is ports and adapters. And this is a very interesting architectural style because it allows you to create very flexible architectures that can adapt to various constraints and various forces that push your architecture to evolve. And I think more teams would benefit from this architectural style, particularly when combined, as we will see. We'll discuss some of the variants, and there are two variants that are very interesting here. And one of them is in combination with domain-driven design. And the second one is functional core imperative shell, which are both extremely interesting in terms of architectures that are flexible, that can be restructured easier, not necessarily very easy, but easier than usual. Later on, depending on the forces applied on your architecture. Before we move on, thank you so much for your subscriptions, for your likes. I got a lot of comments about the live architectural kata that I did the past week. Some people have been asking, when is the next one? Yeah, so maybe we'll do another one. For now, please know that we started a series of these katas that will be that are published now on mosaicworks.com. So this is more of a paid series. So you can talk to your employer and say, this is a really useful exercise, and yeah, I'd like to be a part of it. Visit our website, mosaicworks.com, and look for the Architectural Kata series. With this being said, let's move on to discuss this architectural style. So first of all, where does hexagonal architecture comes from? It comes from Alastair Cockburn. He came up with this idea. He initially named it hexagonal architecture, and based on what he says is that he was thinking about a way of separating the inside of an application from the outside of an application. And the first idea that came to his mind was a hexagon. But the problem with this term is that if you look at this architecture type, it's not really a hexagon because it doesn't have 6 sides. You can have 3 sides, you can have 4, you can have 25. It doesn't matter. The important part is that you have a part of the application that is inside and the outside world. So the better name for this pattern is ports and adapters. And this architectural style is formed out of the following elements that are important. First of all, we have the application itself. And the application is different from the application you are thinking of normally, because the application is just the core of your product. It's everything you can separate. So how would I let me put it this way. You have the business rules, you have everything inside, and then this application communicates with the outside world. And what is the outside world? The user interface, the database, the file system, the services that you are calling, services that are calling you. Yeah, anything else, anything that surrounds the application. So usually another way you can think about this is you should be able to write this application using just the programming language features and run it entirely in memory. That's a good approximation. Maybe it's not 100% correct, but that's the best approximation we can master. So imagine you have this application and then you can plug into it through ports and adapters. So imagine it has ports and you might say, oh, it needs some kind of interaction with the user. Well, we can plug in a command line interaction system. We can plug in a web-based interaction system. We can plug in a REST API interaction system. We can plug in an AI-based interaction system, whatever you want, right? So this is the power of this architectural style. You separate very cleanly your core from the rest, from the outside world. Now, of course, the challenge is that your core needs to interact with the outside world. It needs to call external services, it needs to access data stores, it needs to be called by external services, and so on. And the way we solve this is by creating ports. Now, what is a port? A port is defining the boundary of the application, and in terms of implementation, it's an interface. And Alastair Cockburn recommends calling this interface based on its purpose. So a few examples. For sending notifications, this would be the name of your interface, for sending notifications. And this would be the interface that your application calls in order to send notifications. Now, what is behind this interface, the application doesn't care because it's something that you plug in. And that's where ports come in. Now, you realize that sometimes the port would neatly fit with the notification system. So let's just talk a bit about what notification systems we might have. We might have the Windows native notification system. We might have the Ubuntu iNotify library. We might have the Android notification system. We might have the iOS notification system. We might have notification system that is a SMS or sent through a gateway. Okay, these are all possible implementations for this interface. And now the problem is that not all of these will neatly fit what the application needs from this implementation. Let's assume that for sending notification just has one method, notify and a kind of message. Now maybe some of these libraries have this, maybe others don't and require additional parameters and so on. This is where adapters come in. So you have your application, you have your port defined as an interface. You create an adapter that adapts this interface to the notification system that you want to use. And then you configure everything. How do you configure everything? You configure through a configurator class or subsystem, which knows that for this particular instance of the application, we need the Windows notification system and the SQL Server database and the Stripe payment gateway and so on, and configures everything. And that gives you your application, your complete system. So this is what hexagonal architecture is about. And the key here is having a discipline in separating between the core of the application, the ports, and the adapters. In particular, it seems that the ports have are the most difficult to, well, the adapters actually. The adapters are the most difficult to structure. So there are some additional things here that you need to take into account on how to structure your code so that you don't create a mess. So now understand how powerful this is. Let's talk a bit about some of the benefits of this system. First of all, your application basically runs in memory, which means you can test it extremely fast with automated tests in memory. Everything that is core to your application, you know will work because it runs in memory. It's incredible. Second, you can plug in almost any type of system. So that's why it's so, I was talking about adaptability, how easy it is to adapt this system to other needs. So imagine this, you start with an application that needs to work on Windows desktop, but then you want to make it work on Mac OS. Okay, you still have the core is separate. You just need to implement the adapters. You have the ports, you need to implement the adapters and the configurator, and that should be it. Now, is this trivial? Not always. You might have some hiccups along the way, but it's pretty good. It's pretty okay. It's pretty easy to do. Let's talk a little bit about, because these examples, it was easier to start with desktop-based, but what about web applications? So let's say you start with your core application and you add a REST API on top and you add a React application that calls the REST API. And by the way, the React application could also be a hexagon. That's another thing that would be very interesting. Because basically the React application is interacting with an external API. So that's, again, ports and adapters. That's external to what the application is doing. We can think it like that. But on the server side, you can have the core, and it's surrounded either by a REST API, or you can plug in a web interface, let's say a HTMX style interface that is rendered on server, or you can plug in command line interface, which is really interesting, because then what you can have is a kind of administration tool where you interact with the same application, but you can create, give commands and create whatever you need in order to, I don't know, test the application or configure it or stuff like that. It's just a matter of ports and adapters, right? You already have the core, you already have the port, you need an adapter for the command line, maybe you need an adapter for the REST API. There are a lot of things that you can do with this configuration. And now let's say you're using cloud systems. Okay, so you have your hexagon, you have your application, your core, and you have some things that need to be stored, and you create an interface that's, for storing documents. It happens that this implementation is AWS S3 now. But if you want to switch to another cloud provider, you move there and say, okay, or to another storage system. Maybe you don't want S3 anymore. Maybe you want a managed database. Maybe you want a database that you run on your virtual server. Or maybe you want to switch to another cloud system, and then the only thing you need to do is to implement the adapter for their particular implementation of object storage. Now, is this 100% flexible? Absolutely not. You cannot do anything, everything. This is not possible in general in architecture. Whenever you are creating an architecture, you create trade-offs. In practice, your whole system will require certain capabilities, right? So maybe you need a certain level of scalability, a certain level of performance, a certain level of security. Because you need these influences and limits what you can pick in terms of storage for files or for other things. Which means that if you switch to another provider, one of the things you need to pay attention to is, do we still have the same or similar characteristics as we need for our product? So these are the advantages and the limitations of this architecture, okay? So we have to be very clear here. It is flexible. It allows you to focus on important things, but it has some trade-offs as usual. And those trade-offs are, you need to take into account depending on your particular implementation and context. But you should probably consider ports and adapters for some of your products. I think more applications would benefit from this approach. Now let's talk a little bit about, we discussed the advantages, we discussed the trade-offs. Let's talk a little bit about some variants. First of all, it's important to understand that hexagonal architecture doesn't tell you how to structure this application. So inside the application part or the core part, you can have, as Alastair Cockburn puts it, you could have a domain model, you could have a functional or an immutable kind of thing. You could have a big ball of mud. You could have spaghetti code. It doesn't tell you anything. The only thing this architectural style tells you is we have something inside, we have something outside. We separate the inside from the outside. The inside runs in memory, interacts to the outside through ports and adapters. That's all there is to it. So now we need to add a little bit more to it in order to make it even more valuable and useful. And the first thing that we need to add, I think, is domain modeling. This is something that's really helpful in this case. So if you start from your domain model, which means you take your domain, you identify your domain model, and if you want to see an example of that, watch the live stream on architectural kata. I did an example there. You identify your bounded contexts, you structure your code around those bounded contexts. You implement the domain model with plain old, in your language, objects, POCOs, POJOs, whatever. Plain old Python objects, plain old Java objects, plain old C# or C++ objects, whatever. You create the connections between them, you separate them neatly ideally into smaller modules. We discussed about modular architecture and a modular monolith in a previous episode, so check that out if you are curious how. So you create these modules, and then you create the ports for this thing to interact with the outside world. Okay. And why is this so neat? Because this architecture is fractal in the sense that if I realize, let's say I'm starting with a monolith, I have a modular monolith, I have the ports and adapters. So now not only I have the flexibility to plug in the various implementations that I need, but I can also split the monolith into smaller pieces if I did my domain modeling correctly. So if I need a part of the monolith to get out of it because of various reasons, because it's maybe needs to scale differently, because it needs a different level of security, or because I just want to do microservices, whatever it is, you can extract this, create around it the ports and adapters, and now you have a module that happens to be deployed as a service, but that still has the ports and adapter structure and interacts with the others using the ports and adapter structure. So this is really neat because you can do this type of, you have this type of flexibility as you move along in your development process, in your architecture, as you realize the forces that pressure your architecture in various ways. Another thing that, and another option for this is to move even further and make your whole domain part completely immutable. And that is really cool. And why is that really cool? Because it simplifies a lot everything that you do inside that. So one of the big challenges of functional programming is we have this good idea called immutability. And it's a very good idea because it simplifies everything. Immutability basically means that when you get the same inputs, you'll get the same output. The trouble with functional programming when it comes to real-world applications is when this idea immutability interacts with the other systems around it that require mutability, like file systems, databases, external services, and so on. Those need mutation. And this is where we get all kind of interesting constructs like monads. Not only because of that, but that's one of the reasons. So you can make a very simple immutable structure without resorting to any of those fancy things. If you just make everything immutable in the core, and then everything that is in the ports and adapters is assumed to be based on mutation. We basically separate the core from the rest. And this is another derived pattern called functional core imperative shell. And I'm afraid I don't remember who did it right now, but if you search for it, you'll find definitely who did. And this is a really cool one because now not only you can test everything using automated tests and in memory, well, all your application, let's say, all your domain model. But the really neat thing about this is that you can test this using tests that are data driven. So you basically say, for this set of inputs, I always expect this set of outputs. and you just create rows of data that, input, output, input, output, input, output. And your tests become very, very simple. Now, the cost of it, because there's always a trade-off, is that you need to write your code immutable. This is possible in certain languages and is easier, like Rust or functional programming languages. It's not as easy in other programming languages, like Java, or you need to pay more attention. Also, sometimes, well, you need to decide how far you go with immutability, because there's one thing where it can become more complicated, and that is when it comes to collections. You can have immutable collections, but that means that whenever you add an item or remove an item from a collection, it returns you a new collection. And in order to have that, you need to have the underlying system that optimizes the memory for these kinds of operations. And there are libraries that can do that. You can search that for your programming language, but depending on the performance that you require, that might be or might not be exactly the best fit. You can go with a more relaxed approach in which everything is immutable except for the collections, or you try to use immutable collections, but only for small collections, let's say, in case you need very high optimization. So there's just a caveat you need to pay attention to. But other than that, it's really possible to write immutable core, and so functional core and imperative shell with hexagonal architecture, because it's basically you have an immutable model in the center, and then you just have the ports and adapters towards all the necessary mutations that happen around the core of the application. All right, now let's talk a little bit about the comparison between hexagonal architecture and clean architecture. So clean architecture is a style of architecture that was created and popularized by Robert C. Martin. And I understand many people find it quite compelling. And the reason is, I believe, that it gives you a lot of things already decided for you. You can just start with it. It gives you a structure. It gives you a lot of ideas. Now, the clean architecture and hexagonal architecture are cousins. They are closely related. You can see how the ideas from ports and adapters influenced clean architecture. However, what I personally don't like about clean architecture is that it gives you a recipe that's too strict. And I don't believe it fits every case, every situation. What I like about ports and adapters is that it gives me a structure, but then it allows me enough flexibility to decide how to structure the code inside, how to interact with the outside world, what to do with the adapters, the area of my system, and so on. So there are a lot of decisions that I can make around this that make much more sense to me in terms of architecture than a very recipe-driven solution. So this is why I usually find the clean architecture to be too simple. It's too simple to cover the complexities that we have in software architecture in general. it kind of makes you think that you can avoid a lot of complexity, but it's just, you're just kidding yourself. The complexity will still be there, it will hit you. Whereas with hexagonal architecture, you need to think a little bit more. But in this process of thinking, you realize what are the real challenges for your architecture. And I believe that's really very valuable whenever you're doing software architecture. So don't be fooled into very simple solutions, because they usually approximate a good solution, and when the approximation fails, that's when you'll start having problems. And it's not necessarily the best way forward. But with this being said, experiment, right? You can. I am always in favor of experimentation. Try out different architectural styles. Try out modular monolith. Try out microservices. Try out ports and adapters. Try out clean architecture. These are all architectural styles that you can try. And once again, I believe that the architecture will change in the next few years. Right now, the de facto standard is microservices in most large organizations, but I'm already seeing signs that we're moving slowly away from it. And I think we'll start seeing soon other architectural styles replacing this, the microservices ones, in specific contexts. With this being said, I hope you enjoyed this and you found it useful. If you have any questions, please leave comments. We love comments. We love to get in touch with you. Don't forget, like, share, subscribe. We are very close to 800 subscribers. I think we are at 799. We need one more to be get to 800, and then think about 1000. Why not? Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.